Problem number 10, we're given that the probability that a random individual has diabetes is 14%. 10 individuals are randomly selected. What is the probability that at least one of them has diabetes? Round your answer to 4 decimal places. So this is a binomial experiment because there's 2 outcomes. Either you have diabetes, which is a success, or you don't have it, which is considered a failure. And so our random variable x is going to be the number of individuals out of 10 that have diabetes. And we want to know what's the probability at least 1 out of 10 has diabetes. So at least 1 is a greater than equal. So we want the probability that x is greater than equal 1. So we're going to do that using the binomial CDF function on the calculator. But binomial CDF only does less than equal probabilities. So we actually have to use the complement event here. So we have to do 1 minus the probability that x is less than 1. But the only number that's less than 1 is 0. So this is 1 minus the probability of 0 people having diabetes. So if we use binomial CDF, or for one value you can use PDF, but we'll just go ahead and use CDF because you use that most of the time. CDF, it's n is the total number of trials, p your probability of success, and then x is the number of successes you're interested in. Our p is going to be 14%. That's the probability of an individual success here. So p is 0.14. And so we want to do 1 minus, and this will be binom CDF. And we have 10 trials, 10 individuals. Probability of success is 0.14. And we want to know probability of 0. So our x there is equal to 0. Let's go ahead and key this in. So 1 minus, we go to second variables. Binomial is off the bottom of the screen here. That's PDF. That's for one value. We could use that. Let's go ahead and use CDF, which is going to be cumulative from 0 up to 0 in this case. So our trials are 10. P is 0.14. Our x value is 0. Paste it. Compute 0.7787. Now, if they said, what is the probability that at most 6 had diabetes? So at most 6 would be the probability that x is less than equal 6. So that's already a less than equal probability, so we don't need to use complement there. This would just be binom CDF. And you've got 10 trials total. Probability of success is 0.14, and we're going from 0 up to 6. Put a 6 in there. Go ahead and compute this. So second variables, scroll down off the bottom to letter B. And we've already got the 10 and the 0.14. Change our x to 6. Paste, and 9999. So it's almost 100% probability, 99.999% probability that less than 6 will have diabetes. So anything that you're given one probability and it's binomial, 2 outcomes, either they do or they don't, true or false, on time or late, success, failure. That is your clue. You're using binomial CDF. Now, if they were to ask us, what is the probability that exactly 3 had diabetes? So that's asking what's the probability that x is equal 3. So when you want one value there, you'll use binomial PDF. So this would be binom PDF. So that's probability density function. The C is cumulative. And you do 10 and 0.14 again, and our x value now is 3. So let's compute that. Second variables, Scroll down. So PDF is A. So 10 trials, 0.14 success. X is 3. Paste it. 1146. So 11.46% chance that exactly 3 would have diabetes.